lecture, the first thing I'm going to do is talk about the Wireshark project in the project. If there are people that don't know how to use Wireshark, which I suppose there may be in this course, then you should learn how to use Wireshark. And you'll find that down here at the bottom in the networking section. It's extra credit, but I highly recommend it. This is a bit of fun. You install Wireshark on any machine you want. It'll run on any operating system, although I guess not on an iPad. It'll run on Linux, Windows, or the Mac. And then you download this file. And so I'll just briefly demonstrate the beginning of this so you can see it. This is an FTP login file I made. And once you have Wireshark, you can just open it in Wireshark. And it will open the saved packet capture. So here you see it. So right now, it's the frames are sitting here. I have 296 packets. And so when I was beginning with Wireshark, I would look at this top frame and follow frame by frame. So here it is doing a SYN-ACK handshake somewhere. Here it is connecting to Dropbox, something about Dropbox. Then there's a bunch of SYNs. This is pretty baffling. Looking at packets one by one up here, you won't really be able to get too far that way. That's the way complete beginners use Wireshark. What's a lot better is to use the tools that get you more details. But anyway, this is essentially what you see if you're on tcpdump. This is a one-liner summarizing each packet. So this is going from that local address, that source address, to that destination address, that destination port, TCP, and it's a SYN packet. So you get a general summary of the packets here. Here you see a breakdown of the packets in this middle pane, which is pretty useful. So for example, here I've got a DNS query. So a DNS query is here, and this gives you the OSI model if you've taken your Network Plus. This is the bytes on the wire, that's at the physical layer. Here's at layer 2, Ethernet. It gives you source and destination MAC addresses. Here's layer 3, giving you source and destination IP addresses. And here's layer 4, giving you source and destination UDP ports, because this is a UDP packet, like most normal DNS packets. So all this is the addressing information to get it where it was going, and this is the actual data that was sent at a higher level. Usually layer 7 is what you call it. And so here it says a question and answers. Here's the queries, and there's the query. It wants to know the IP version 6 address for bolt.v.dropbox.com. That's what this means. It lets you see the contents. So that's what a DNS query looks like. And here's a response, which shows query. And here's the authoritative name servers. And it looks like maybe it didn't get a response. For standard query response, no enters. Those are flags. All right, anyway, then you've got other kinds of data here. So you can, by the way, at the very bottom, you've got the raw packet in hexadecimal and ASCII, and you usually don't worry about that. You're pretty desperate when you go down to that level. Normally, you stick in the top 2 panes. But now, I'd like to find FTP. So to find FTP, what you do is you use the display filter. The display filter is extremely wonderful. So for example, if you thought there was HTTP, there you can filter. There is no HTTP in this traffic. You can filter for TCP. I saw that. And you can filter for DNS. And what it does is it just shows you only those packets. It's very nice. And so if you filter for FTP, notice it suggests FTP and FTP-data, because if you know FTP, or if you Google and look it up, FTP has 2 streams. There's the FTP stream, which is used to negotiate with the server and send up a username and password. And then there's the FTP data that is used to transfer files after you've made that connection. So FTP will show us login, and here we go. Here's somebody, please log in with user and password. Here's a username, there's a password, then they've logged in successfully. And notice FTP doesn't encrypt anything. The password is just sitting right there. So you can just see it. And once they've logged in, maybe they sent some data. If we use FTP data, I guess they did not actually send any data in this thing. All they did was log in. If they'd transferred a file, we'd see it there in the FTP data. So anyway, there's a flag defined here by just reading the FTP packets. And then there's one to do with HTTP login. So people used to do this a lot more than they do now. They'd make web pages that have no encryption and log in over HTTP. And so I need to clear the filter. Okay, here's this stuff. Again, this one has 92 packets. And the green is HTTP. And here it is going to some login and sending some stuff. So somewhere in this mess, here it sent a GET to get a login, and some of this data down here, it must have sent the login. And there's various ways to find it, but a good way to see this kind of thing, one thing you can do is filter for HTTP, and then you see the HTTP packets go by, but you see it has several attempts to log in here. These posts send up a login. Now you can examine one by clicking on it and looking here, and you'll see form URL encoded data, and if you expand it, it will show you there. Here's username and password, submit. But it might have been right and it might have been wrong. You'd have to tell by reading later packets to see if it was right or wrong. But another thing that is really useful, when you have a series of packets that are all part of the same stream of transmission here, is you right-click on one of them and follow TCP stream. And now you see a nice display of essentially what the user saw. They sent this GET, they got this answer. They sent this GET, they got that answer. And that's what happened. So you might be able to tell what's going on here. That's a keep alive. That's the reply. This particular one is not very useful. But let's go to the ones containing login. Like this one. This one has something not found. Oh, that was favicon. Here something was found. But that's just loading the login page. It's the, let's go back to HTTP here. It is the posts that contain the data, the login. So let's follow a post. Follow TCP stream. All right, now here it is logging in as Isaac and Flapper. And the response is encrypted, and I can't see whether it worked. All right, and let me just see my instructions give you any hints what you're looking for here. Expand it. All right, there's the Flapper, and so you follow a stream, and the reply is zipped. So if you go back to here and view the reply, you'll now be able to see it unzipped. So what you can do is go to this one, packet 51. Here's 51. So here it tried to log in, and here's the reply in packet 51. And when I followed the stream, this packet was encrypted, but it was actually compressed, not encrypted. And see here, Wireshark will decrypt it there. So let me show you. This is often the case. If you follow the stream, it will show you the ASCII contents, and the problem is this is the reply from the server, and it's just compressed stuff you can't see. But Wireshark decompresses it and shows it when you view it here. So now I can see this login was denied. So you can do that for each of these logins and find out which one of them actually had the right password in it. So anyway, that's the easy stuff here. And then there is something I got from Red Team CTF, which is a very good capture the flag contest, which is an APT capture. And this one is very nice. It got it last year at a capture the flag contest. It's got one encrypted protocol you can find. You can find out what tool was used to perform the encryption. The tool was actually transferred over the network, and you can get the complete file and get the hash of it. You can find the private key transmitted, and you can decrypt the stuff, and a lot of things you can find in this one if you're up for a challenge. That's all extra credit, of course. This whole thing is extra credit. But there's enough there to be kind of fun, even if you're relatively sophisticated at using Wireshark. So check that out. If you haven't used Wireshark a bit, you should do at least the first few of those and get some familiarity with it.